Hey everyone, welcome to homework 3.iRT. Today was iReady testing, so this is kind of a unique homework, but it is also some good practice. So it says, which one doesn't belong? Now this is kind of one of those situations where there might be more than one instance of something not belonging. So let's take a look. In this first one, we could say the first one doesn't belong. Why? Well, because it is a decay factor. Or a decay model, and so we could say A because it is the only one that decays. Okay, now B we can say is different because it is linear. C we can say it is different because it has a starting value of 10. All right, that's the only one that's happening there. All these other ones are starting with a value of 20. And then D, we could say that it is not a graph, right? It's written as an equation. Now here in this one, we are multiplying by 2. It appears that here we are also multiplying by 2 each time. If we were to look at 0, 1, consecutive order, right? 1, 20 would be here. So it looks like this one's also multiplying by 2. So really the only difference here is that this is starting at 20 and that this is not represented by a graph, but represented by an equation or an equation written in function form. All right, consider the graph of f of x equals 3 times 2 to the power of x and the corresponding table. Using the first 2 points, what is the growth factor? So you can look here, or we can look here, but either way, we're going to do 6 divided by 3, so we know the growth factor is 2. We're multiplying by 2 each time. Using the second 2 points, what is the growth factor? So now, now we're going to look at these 2 points, or these 2 points, and then we again get 12 divided by 6, which is also 2. Where do you see this growth factor in the equation? So this would be in the 3 times 2 to the power of x. And so this is the 2 equals b in the equation, right? So here it is the base of the exponent. Okay, where do you see the growth factor on the graph? So here on the graph, we can see this growth factor in the y values and how they are multiplying by 2. Y values are multiplied by 2. It says, what is the vertical intercept of the graph? So that is right here, and that is 0, 3. And we can tell from the equation that this is the vertical intercept because it is the value for a when x equals 0, or the starting amount, then y equals 3. All right. Consider the graph g of x equals 8 times 1/2 to the power of x and the corresponding table. So this is a similar thing. Using the first 2 points, what is the growth factor? So we're looking at these 2 consecutive points. 4 divided by 8 equals 1/2 or 0.5. In this case, it is a decay factor, right? They're using the term growth factor, but in this case, we're decaying. Using the second 2 points, so same thing. We're going to do 2 divided by 4 equals 1/2 or 0.5. We see this growth factor in the parentheses of the equation. So it is again, the base of the exponent. And it would be where b in the equation a times b to the power of x, it is b. Where do you see the growth factor on the graph? So again, we see this y values are going down by half each time, or halving each time. The vertical intercept of this graph is 0, 8, and we can tell from this equation that this is the vertical intercept because if we were to put into the equation, we have 8 times 1/2 to the power of 0, right? Then this equals 8. And so this then, when x equals 0, y equals 8. The output equals 8, or you could say g of x. So when x equals 0, g of x equals 8. All right, our last part here is very simply just matching these equations with the graphs, which ones are which. So let's start with this 300 times 2 to the power of t. So we know for this one our starting value will be 300, so we're looking at a y-intercept of 300 and increasing by double each time. So this is an increasing value here, and so that helps me to recognize that this is probably going to be graph 8. Here we have a y-intercept of 300, and this is the only graph that is also then increasing. Oh, actually, I'm mistaken. Sorry. There's one here that is at 300 and also increasing. So let's look at graphs 1 and graphs 8 and compare them. So here we go from 300, and then at 1 it is at 600. So that appears to be doubling. Whereas here we go from 300 and then we go to, looks like 900. So this one is tripling. So that tells us then that this one is a of t equals 300 times 2 to the power of t. And that this one then is b of t equals 300 times 3 to the power of t, because this is tripling. All right, so let's look. So we've got these two done. Let's look at c of t. So this one is decreasing, also starting at 300, but decreasing by half. So at 1, it should be 150. So let's take a look here. This is starting at 300. At 1, it's going further down. It's going to 100. This one's starting at 300, and it's going down to 150 at 1. So this would be this one right here. C of t equals 300 times 1/2 to the power of t. And that means this other one that I just looked at, where it's starting at 300, going down to 1, it's going down to 100, means dividing by 3. And that would be d of t equals 300 times 1/3 to the power of t. All right, so those two are done. Okay, so similar process that I just did for the remaining 4, I want you to do these 4 on your own. So you should be matching those up. You're looking at the starting value of 108. The rest of the graph should all start at 108, right? We're looking about here-ish, right? And then you're looking at whether they're increasing or decreasing and by how much, right? If this number is bigger, it's increasing faster. If this number is smaller, when it's a decay factor, that means less of it remains. So it's decreasing faster, and that can help you to match up with the correct graph. So let's see here. Yep, yeah, so as an example here, 1/3 remains versus 1/2 remains. So this is steeper, it's decreasing faster because less of it remains. Here, 1/2 is more than 1/3, so it's retaining more of it, so that graph is not as steep. So same thing here, you're looking for, this is reduced by half, which means it is decreasing slower. I think I might have said the inverse earlier, but this is decreasing slower because 50% remains, where this is 33% approximately remains. And so that means this one is decreasing faster because less of it remains. All right, it says on 2 of the graphs show where you can see the vertical intercept 108 and 300. So pick any 2 graphs and you're going to go ahead and show where those vertical intercepts are. So I might show here. It's a vertical intercept, and I'm going to go ahead, let me change the color to make that more visible. Label it 0, 300. And I'm going to do that on 2 of the graphs. Let me find another one where that's the case. Here is 0, 300. And then it says on 4 of the graphs, show where you can see the growth factor, 1/2, 1/3, 1/2, 2, and 3. So that would be where we're looking at our, for example, here, we're starting at 300 and going to 600. So we're showing that 600 divided by 300 gives us, or sorry, by 200. No, by 300. 300 gives us 2. That's our growth factor as seen here, right? Because this is 300. Another one that you might show might be here, 300 and 100. So we do 100, later value over early value equals 1/3. Okay, so you're showing on that graph, it says on 4 of the graphs. So I showed you 2, do 2 more. We did 2 and 1/3, so do 1/2 and 3. You can find that and just show us how we would get that factor from looking at the graph. All right, that is it for your homework. Today's code word will be pocket. Pocket is your code word. Go ahead and put that at the top of your paper and you can earn extra credit. Happy homeworking and see you tomorrow.